5, 4, 3, 2, 1, 0. And lift off.
Good afternoon. It is Monday, July 20th, and on your screen is a live view of the rocket as it awaits its 5:30 p.m. Eastern Daylight Time launch from Cape Canaveral Air Force Station in Florida. My name is Michael Andrews, and I'm a supply chain supervisor here and welcome to our webcast coverage for the Anasis 2 mission. Our customer today is Lockheed Martin on behalf of the Republic of Korea. Per the customer's request, we will not show payload deployment today. However, we will stay live on the webcast and bring you verbal confirmation of spacecraft separation. We are just at under T-minus 11 minutes and counting, and all systems are go for an on-time liftoff this afternoon. But if for some reason we are not able to launch today, we do have a backup window tomorrow at 5 p.m. Eastern. Now let's take a closer look at the vehicle that will launch our payload today. On your screen is that view of Space Launch Complex 40 with rocket. It's our two-stage liquid-fueled launch vehicle getting ready for liftoff. At about 230 feet tall, 70 meters tall. That's greater than the wingspan of a 747 aircraft. The bottom two-thirds of the vehicle is the first stage. It's designed to be reflown 10 or more times with minimal refurbishment between flights. And as you can tell from the re-entry soot on that first stage, it's pretty easy to spot a flight-proven booster. Today will be the second flight for this particular first stage, and actually less than 2 months ago, it was the one that launched Bob and Doug to the International Space Station on our historic Demo 2 mission. At the bottom of that first stage, there are 9 Merlin engines. They get the ground up to the thinner parts of Earth's atmosphere before separating from second stage and making its way back down to Earth for landing. And it's this part of the rocket that we will attempt to recover for a second time on our drone ship, known as Just Read the Instructions. You can see it there. It's stationed 350 nautical miles east of our launch site. And above the first stage, above that black interstage band, is our second stage. At about T plus 2.5 minutes into flight, the first and second stage will separate, and that second stage will ignite its single MVAC engine. That'll carry the Anasis 2 spacecraft to its intended orbit. And the Anasis 2 satellite is currently safely enclosed inside the 17-foot diameter payload fairing. It's that structure on the very top of the rocket. This protects the satellites from aerodynamic heating, loads, any kind of contamination that they might experience during ascent. But once we reach the vacuum of space, we no longer need those fairing halves, and we jettison them while the second stage continues to orbit. The fairing halves we're using today are a brand new set, which means we'll be attempting to recover them today using our 2 recovery ships, Tree and Mischief. 2 minutes before the fairings are set to land, the team will decide if conditions are good to make a safe catch attempt. Now, weather plays a big factor in the decision, as it can impact not only the sea states for the boats, but also the fairing's altitude, position, and speed, all of which impact how the fairing will fall back to Earth. And finally, around the rocket is that large truss structure. It's called the transporter erector. We call it the TE. The TE rolls the launch pad and raises it to that vertical launch position, and also routes things like power, fluids, and communication to the rocket and satellite.
Hi, I'm John Innsbrucker, integration engineer here. We're coming up on 8 minutes to launch, and all conditions continue to be go for launch. Out to the pad Sunday afternoon, about 25 hours before launch, and went vertical 4 hours later. Now, more recently, this launch director held the go, no-go poll for both prop load and launch. That was done at T-minus 38 minutes. Now, we're currently working, no issues on the launch vehicle. If we do have to call a hold on today's launch, we have a nearly 4-hour window that could allow us to reload the ultra-cold liquid oxygen and make another launch attempt today. Of course, that presumes that we understand whatever caused us to hold the count and we can safely proceed with a recycle and launch. Now, if we cannot continue today, we have a backup opportunity tomorrow at 5 p.m. Eastern. Now, we've been loading propellants on since T-minus 35 minutes, putting fuel into both stages and oxidizer into the first stage. Our fuel is the refined form of kerosene known as RP1. The fuel is fully loaded on the second stage, and we're going to finish loading the first stage in about another minute. Now, as I mentioned a moment ago, our oxidizer is super chilled liquid oxygen. We call it LOX. Now, the LOX is currently loading into both the first and second stage. You can see the mist streaming off of the first and second stage tanks.
Engine chill has started.
Now, I mentioned it is super chilled. We do this in order to load more locks into the tanks and increase performance. Typically, launch providers use locks right near its boiling point of about 300 degrees below 0 Fahrenheit. Especially the lock's about 40 degrees colder. That makes it denser. It lets us load more into the first and second stages. Now, we have to load the locks as late as possible to keep it from warming up and decreasing the performance. We're also finishing helium loading onto the first and second stage tanks. Now, as the Merlin engine pumps pull the RP1 and locks out of the tanks, we need to fill that emptying volume that we call the ullage. We use the helium stored in pressure vessels on the stages, and it's heated by the exhaust of the engine's gas generators. Heating the helium helps it expand to fill the tanks. Now, a moment ago at T-minus 7 minutes, we heard engine chill begins. We're now allowing a small amount of the super chilled liquid oxygen to flow past the turbopump inlets. That's cooling them down to avoid thermal shocks when we light the engines at T-minus 2 seconds. On the spacecraft side, the team did transition the Anasis 2 payload to internal battery power starting inside of T-minus 30 minutes. That work is complete, there are no issues, and there are no further actions required before launch. We're launching out of the eastern range. The good news is air and sea space is clear. Weather balloons that have been released show the upper altitude weather is good. We did have to delay the T0 30 minutes for a small rain shower that was crossing the trajectory path. That was moving out of the way, so right now weather looks to be good for a launch in just over 5 minutes as all systems continue to be go for liftoff at 5:30 p.m. Eastern Time.
As we mentioned earlier, our customer today is Lockheed Martin on behalf of the Republic of Korea. We now have a quick message to share from Korea's President of the Agency for Defense Development.
We have closed out the first stage liquid oxygen load. That just leaves stage 2 locks loading to finish. That call out tells us that the chill sequence we began at T-minus 7 minutes is now complete.
Stage 2 lock load is complete.
That completes propellant loading on stage 2 LOX load, the last one to finish up inside of 2 minutes. We'll now begin venting down the plumbing lines that go up that strong back that you can see behind. So if you see a plume of white gas coming out, that's normal. You can see in the view from the camera, we're now venting down the liquid oxygen lines on the strong back, getting ready for launch. Next event will be startup, coming at T-minus 1 minute.
So startup.
Here's the call out. We're in startup. We're now pressurizing first and second stage tanks for flight.
LD countdown net, go for launch.
There we go. The final call to launch director is given to go for launch. We're at T-minus 35 seconds and counting. All systems are go.
T-minus 30 seconds. Stage 1 tanks pressing for flight. Stage 1 tanks pressing for flight.
T-minus 15 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition. Liftoff.
40 seconds. Everything looking good? That's the call out says inward engines are throttling down, getting ready to reduce vehicle acceleration in preparation for the period of maximum dynamic pressure. And the bottom of the throttle bucket, as they call it. Now the Merlin engine's coming back up to full power as we get ready to go supersonic.
Equal is supersonic.
Supersonic, we're coming through the period of maximum dynamic pressure.
Equal has reached maximum aerodynamic pressure.
Planes engineer confirms we're through the period of greatest pressure on the vehicle. Continuing downrange, trajectory looks good. Propulsion looks good. Avionics looks good.
Convecting chill has started.
An announcement from stage 2 propulsion. We are now beginning to chill in the turbo pump on the upper stage engine to get ready for its ignition coming up in about 45 seconds. Nice view from the SpaceX cameras at Cape Canaveral as we head east out of Space Launch Complex 40 into the first of 2 orbits planned for today. This orbit is the parking orbit, the low Earth orbit trajectory that will take us over the equator, and we will eventually relight the upper stage engine to transfer us into the desired geostationary transfer orbit. Now, main engine cutoff, or MECO, coming up in several seconds, followed by pneumatic separation. The first stage pushes away from the second stage, and then ignition of the second stage engine.
Stage
Miko.
separation confirmed.
MECO on time. Stage sep looks good. And the call out MVAC-D engine is at full power. The view on the left screen, you can see the large titanium grid fins now slowly opening. That begins about a 2-minute period as we slowly rotate the first stage around to get it ready to come back through the atmosphere and land on the drone ship in the Atlantic off the east coast of Florida. Welcome back to the webcast carrying the QcatilA 5B satellite designed and developed by Airbus. We're coming up on the second burn of the upper stage engine in just under 30 seconds. Now to recap what's happened so far this evening, we had a smooth liftoff at 10:58 p.m. Eastern Time. 2.5 minutes later, our first and second stages successfully separated. The first stage, which made its third flight today, landed on our drone ship, a shortfall of gravitas. Now the second stage completed its first burn, and that successfully inserted today's payload and second stage into the parking orbit you see on your screen right now. We're getting ready to relight the second stage engine to put us into the geotransfer orbit.
And back, restart ignition.
We've got ignition of the second stage engine. We're up on power. Now at this point, the second stage will burn for about 1 minute before shutting down for the second time. This shutdown event is called SECO-2, which stands for Second Stage Engine Cutoff Number 2. And this burn will place the QcatilA 5B satellite into the required orbit prior to separating it from. Now, as you can see, during this burn, we're going to add about 2,700 meters per second, almost 6,000 miles per hour, to the speed of the Falcon 9 second stage. And that's going to take us well in excess of the standard GEO orbit of 35,000 kilometers. We're hearing tank pressure is looking good, engine performance, and looking good. Engine performance looks nominal. And we've heard, we've got shutdown of the second stage engine. You saw it briefly there on the screen. And in the background, we heard nominal orbit insertion. So that's the good orbit call out that we always like to hear. So as a reminder, for those tuning in, the QcatilA 5B satellite is still attached to second stage.